Good day, everyone, and welcome to this session. It's really my pleasure to host this. My name is Subodh Maisalkar, and along with three distinguished panelists, we're going to really cover topics of renewable energy and climate neutrality. Before we begin, it's really our pleasure to be here with you. We have participants from more than 40 countries, and we expect more than 300 to 400 people to join us in this session. I don't think I need to highlight to the young people who are tuning today that climate change is one of the greatest challenges that we are facing for the 21st century. IPCC has called on all nations to make strong efforts to cap the global temperature rise to 1.5 degrees centigrade to avoid catastrophic climate change. By now, countries and corporations are beginning to respond. We have more than 120 nations representing 53% of global GDP who have made binding targets or binding commitments to reduce their emissions by 2050. More than 125 companies that include organizations such as Apple, Microsoft, IKEA, Nestle have committed to become carbon neutral or climate positive over the next 2 to 3 decades. We all know that the solar as well as wind renewables have made tremendous progress over the past 10 years. But I think it's also known that renewables alone will not deliver on climate neutrality. And that's really one of the key reasons we are having these sessions. We are looking at questions in terms of what is needed beyond renewables, beyond hydrogen, beyond carbon capture and utilization, beyond carbon capture and sequestration that we need to address. What are the opportunities that delving into basic fundamental science will open up breakthroughs to address challenges in terms of climate neutrality are some of the key questions that we will pose in today's panel discussion. It's really my pleasure to call upon distinguished panel members to shed light on this subject. We are joined today by Professor Stanley Whittingham from Binghamton University, who received the Nobel Prize in Chemistry in 2019 for the development of lithium-ion batteries. We are also joined by Professor Kelo from University of Cambridge and University of Geneva, who also received his Physics Nobel Prize in 2019, but for the discovery of an exoplanet orbiting a solar-type star. And we're also privileged to have Professor Kajita with us from the University of Tokyo, who's a recipient of Nobel Prize in Physics in 2015 for the discovery of neutrino oscillations. Given that we have more than 200 participants in this session, we have sort of divided the session into 3 or 4 different parts. We'll start off with a primer introducing the subject. We'll speak about climate change mitigation. Then we will also touch upon breakthroughs that are needed, and this is where we look to basic science to generate next generation solutions, and we'll end up with some concluding remarks. One of the things we would really like to do is open up the session for question and answers. So we would take your questions as they come in, or perhaps towards an appropriate break within each of the sections, and I'll invite any of the panel members to jump in and ask and respond to your questions as they come. So let's kick off the primer section of today's discussion. Firstly, let me start with inviting Professor Whittingham to set the stage, really responding to questions such as what exactly are we looking at in terms of challenges posed by climate change. Over to you, Professor Whittingham.
Thank you very much, and hello, everybody. If we are to reduce climate change and get a cleaner environment, and I emphasize that because we burn coal, we also emit mercury and other contaminants, so it's more than just CO2. We need to reduce the combustion of fossil fuels, such as coal and oil. And our goal really has to become carbon neutral. That is, we take in as much CO2 as we produce. And just earlier this week, the United States announced that last year they produced 10% less carbon dioxide than in any of the previous 10 years. Obviously, this was due to the pandemic. We have to make sure we don't go back to the old normal. So we really need to use renewables, and these, particularly in the US, mean solar, wind, and there's a lot of hydropower, particularly in Washington State and a lot of Canada. We can use that. And the ease of using renewables, we have to remember, varies very much from country to country. But in the United States, well over 90% of all the new generating capacity is renewable. And that's because they now have a lower lifetime cost. They don't have to be subsidized. So utilities are not installing coal power plants. And I should emphasize the slight complication in the United States. Each state has its own policy. So for example, New York and California have already signed on to go carbon neutral before 2050. And I think California is banning internal combustion engine sales by 2035, and Britain's doing that by 2030. But if we have renewables, our big challenge is we need storage, and I'll talk about that a little bit later. But storage has really taken off in the last few years. So within the next few days, there will be a large lithium-ion battery storage facility opening up in Moss Landing, California. This is 1.2 gigawatt hours, several times larger than any other system in the world. And they have permission now to go to 6 gigawatt hours. So the utilities are saying this is the way to go. We can make money doing this, and it's better for all of us than using fossil fuels. And I'll stop there. Thank you all.
Thank you, Prof. Whittingham. If I may turn to Professor Kajita, and I think Professor Whittingham also alluded to this. I think there are many differences from a societal or cultural perspective. Prof. Kajita, could you share a little bit of your thoughts in terms of, I mean, what does it mean to look at sustainable development from a cultural perspective, and especially from given that the Japanese have a particular way of pursuing sustainability? We would like to hear from you, please.
Yeah, okay, thank you very much. Well, certainly, when we think about the sustainability, everyone must be involved. Therefore, the cultural aspect is very important. Therefore, I want to mention some of the Japanese ways of sustainable living. First, our generation or previous generations were told not to waste food and other things. I think which is very good. If we waste much food, this will be one of the big issues in sustainability. This used to be an important part of the Japanese way of living, which in my mind should be acknowledged by the younger generation in Japan and in many other countries as well. But recently, the loss of food has become a serious issue in Japan. Likewise, people seem to recognize the importance of reducing the usage of electricity, or in other words, usage of fossil fuel. But in my opinion, people's mind to reduce the carbon dioxide emission substantially is not very strong. For example, as of 2018, the fraction of houses with solar panels in Japan is only about 6%, very low. I hope that people in Japan realize the seriousness of the global warming and will take stronger action toward the carbon neutral. But that's all from me for the moment.
Thank you, Prof. Kajita. Prof. Kelo, if I may turn to you, please. I think one of the things that we have often looked at from a science and technology perspective is solutioning without the consideration of techno-economics. I wonder if you can comment on how we should look at climate change, really keeping economics in mind.
Yes, I think I like to bring some more astrophysical perspective here. I think there is something that we should all be aware is I think the use of the word climate change is extremely mild and doesn't give the whole picture what's going on. And I think we should start considering changing the wording here because the wording has an impact. It's a human impact activity problem that is changing the climate, but the climate is just changing by itself. We are engineering this planet. We are changing it. So I think we should really all come to the point where debate about the rationale of the climate change is just irrelevant. And that's why we should just agree to changing the wording here and talking about human impact on the atmosphere. We have modified. We are changing the natural balancing of the planet. This natural equilibrium, which is related to the nature of the atmosphere and the Earth physics, is being changed by us. We are the only responsible for what is going on. So I think this is our responsibility now to accept the situations and to stop arguing endlessly about the rationale of what's going on. We are changing it because we're just putting a lot of gas, which are not naturally into the atmosphere, into this atmosphere. One of them is the CO2, but that's not the only one that we are bringing into the atmosphere. Now, if we accept this fact, we have to bear the consequences. This situation is well understood that the change of the temperature of the planet, that we're doing an extremely fast process right now, is going to have a lot of impact. This impact has been assessed by people trying to cost it. If you change the height of the ocean, you will have a lot of trouble with all the cities which are just next to an ocean. And it turns out that human being likes to be next to the ocean because it's a very natural source of food. So you turn out to have a large fraction of the population which is at risk of not being able to stay anymore where they're living. So it's mass motion of people. There's also a deep impact on the whole economical system that we're putting under stress right now. So I'm extremely worried right now by still seeing some people debating about the rationale of this climate change. And I think it's time now to change the wording and to talk about human impact on atmosphere on the planet rather than climate change, because it's one of them, and to really try to address the economic impact. The economic impact will be huge on a very short amount of time. And we're already seeing them going on. And we see an increase of fire, we see increase of water issue, we see a very dramatic rainfall and snowfall and increase of hurricane. I mean, all this element is related to the increase of the energy which is now stored into the atmosphere of the planet. Now, the fact is the first element that we should accept. Once we have accepted the fact, we have to realize that through the history of humankind, we have been very creative about dealing with our own resources. So I don't see any reason why, with the amount of creativity we have, with the high level of the science development we're having, we're not going to find solution to that. But it may not be enough to expect that science will solve everything by fixing the mistake we have done. We should also maybe thinking a little bit on the way we're using the resources. There is only one planet. There is a given mass, a given amount of energy available in this planet. There is only one sun which is giving this energy right now, and this is very limited. There's no way we can get something else. So it's good now to think about the way we're using these resources in the best way, in the most optimal way, and I think we have plenty of solutions. We just have to decide that it is now time to allocate the right amount of resources and the right amount of people developing these solutions and these global discussions. How are we going together to keep living in peace on this only planet we can live in right now?
Right. Thanks, Professor Kelo. That really propels us into the next section of our discussion. And you mentioned solutions. I would really like to kick off a discussion on mitigation or solutions to possible climate change issues. And to begin with, I'd like to invite Professor Whittingham to comment on energy conservation as well as energy efficiency. Over to you, Professor Whittingham.
Thank you very much. I'd like to just make one other point. Bill Gates has described climate change as a worse pandemic than our virus. Because we can see the virus, we can attack it. Climate change doesn't affect us so much today. We need to worry about the future. So we really have to do it as just being described. Really, we have to convince the politicians to do something and the community. But the simplest way to mitigate change is to reduce the consumption of energy. And obviously, I think in Japan, you're very good at this and relatively good in Europe. So if we look at North America, and that's US and Canada, we use double the amount of energy per capita than Europe uses. And as we just described, this is really a culture issue. Americans want everything now, they want convenience. And I still remember when I first started out working for Exxon, we carpooled to work. No one wants to carpool these days. They all want to have the convenience of coming and going as they like. So I think what we have to do, we need to conserve the energy. And I think that should be fairly simple. And we need to use more energy efficient devices. And an excellent example of the latter is the replacement of the old incandescent light bulb by LEDs. LEDs are, 50, 60% efficient. Light bulbs were, 5% efficient and mostly heat. So we have to look at every new device, and this includes our computers. And I think it also means, and I think all of us used to travel all the time. I think we're going to, I suspect, eliminate a lot of travel. We can do a lot of meetings as we're doing it here and eliminate the CO2 produced here. Most renewable energy sources are intermittent, and this brings us a real challenge. So we have to have large-scale storage. Also, the amount of energy used varies from season to season. So the largest storage facilities are pumped hydro, and these are gigawatts of power. But they are, I think, impossible to make any more, certainly in most of the Western world. So what we need is batteries. They are flexible. They can go in a home solar system. They can go on the grid. But the challenge today is their cost and the high usage of energy to make them. They are not really, in that sense, sustainable. So to manufacture 1 kilowatt hour of battery takes 60 to 80 kilowatt hours of energy, a huge amount. So we need better materials, better processing, so we can eliminate at least 50% of that energy. And we have to make them sustainable, not just toss out like we do with most of our cell phone batteries. Everything has to be recycled. Thank you.
Thank you, Professor Whittingham. There are many, many questions which are coming onto the chat boards. And what I thought we would do is we would continue, inviting our panelists to make some comments before taking these questions. So I would like to, now turn to Professor Kajita. Could you speak a little bit about renewables and also from the perspective of Japan in terms of deployment of these renewables? Of Kajita, you may be on mute.
Okay, yeah, but I'm supposed to discuss the renewable technologies in Japan. But in fact, the technologies should be similar to the other part of the world. In 2020, the Japanese government has announced that Japan will achieve carbon neutral in 2050, which is very encouraging to me. And many people say that in order to achieve carbon neutral in 2050, the carbon dioxide should be reduced by approximately a factor of 2 by 2030. And therefore, it is clear that we have to use the existing technologies as much as we can. And it seems that the Japanese government is thinking the fraction of the renewable energy will be around 50 to 60% in 2050. In this case, you'd have to know what are the remaining 40 to 50%. And according to the Japanese government, 30 to 40% are by the nuclear power reactors and fossil fuels with carbon recycling. I guess we still need the substantial R&Ds to the carbon recycling. Then the remaining 10% of the electricity could be generated by hydrogen and ammonia, where the substantial R&D seems to be necessary. So, well, I said that the renewable energy will be around 50 to 60% in 2050. And in my opinion, the reason that the government does not think higher renewable energy rate is due to the unstable and somewhat unpredictable nature of the renewable energies. Therefore, I think the very important key technology for the renewable energy should be the energy storage, including batteries. So that is what I am thinking.
Great. Thank you, Prof. Kajita. Prof. Kelo, could you comment a little bit from the perspective of policy as well as how, the renewable energy or its deployment is being looked upon in the Western Hemisphere?
Yeah, I think the policy here is certainly a very important topic and possibly the solutions to that problem. And for sure, the scientists will keep working and they will provide ways to build machinery that will be less more energy efficient. And we may get rid of some of the heavy polluting mechanism, but still, I think we are very greedy about energy, and our society is built on the use of energy. So we have to acknowledge that there is certainly the energy is part of the society, and if we assume that the energy has an impact, the use of this energy has an impact on the climate and has a cost, I think we should really ask people dealing with the costing aspect of this. I mean, how much is the cost really by moving the temperature up by 2 degrees? Because this is coming up. Well, now, if we know the cost of this, and we'll be talking about certainly thousands of billions, I mean, this is really a massive amount. Some number has been circulated around this. I think we should just share the cost. Who is making it is going to pay for it. If you're breaking somebody's car or breaking someone's house, well, you have to pay for that. It's very visible. It's very clear. Well, there's no reason why we should not be applicable the same kind of principle about the pollutions. So let's just have what I call the real cost of the use of energy. I think one of the problems is we don't really assess the real cost on the long view when we use something. It's not only about the cost of building it or having a fair salaries for the people that is going to produce it. It's also what is the cost for the whole society, what you're producing. And I think here policy is really very critical. And that's one element, which is essentially tax policy and the way we just add the true cost of anything you're doing. So there's another policy as well that could be considered is how do you stimulate creativity to trying to help? I mean, there are certainly ways it was mentioned to help and to ease the problem. How could you do more? And if you look at the numbers right now, the fraction of the cost of the GDP being spent to develop solutions, it's just very marginal. It's a few tenths of percent in average that you spend for that. Think about how much of the fraction of the GDP each country is spending to allocate for defense budget or to any other budget. Well, I think we should really revisit that and assume that I think in a way we are doing something that on long term will be worse than any worse war you can think about, because this is going to damage the whole living situation on our planet. And this is where I think we should go beyond science. I think the scientists did their job. I mean, they said 20 years ago that we are making something which is a monster here, and people had difficulty to understand that. No, I hope that the more and more evidence that we're having right now is gaining more support there to understand that the scientists are right. And how can we get more respect for the scientists? Well, I don't know. Hopefully the COVID would help. It's a very sad story that you need a pandemic that was predicted years ago by scientists to really acknowledge, oh, this is real, this is going on, and all the solution that was, mentioned by the scientists. Well, they all have been implemented, but essentially because people were forced to do it, but they could have done it much earlier because the solution was pretty clear. Now, all this is about the way you connect with the science and the society, and I think the more you stimulate the interest for science and the knowledge-based attitude, whatever science in a broad term here, the best we're gonna fix this situation. So it's a very complex problem. We all have our share, and I think we should not have a discussion with the scientists, but we should have a serious discussions about people building policies, about lawyers who are responsible for that, and asking people that costing all this. I mean, they do the job to cost it. When the bank is invested money into industry that are massively increasing the temperature of the planet, well, they should be liable for that, and they should be held responsible for that they are messing up the planet. So all this is a very complex a network of solutions, which should not be only on the hand of the science, but certainly fully at hand of the governments and policy, society, law, and then true costing of this impact.
Great. Thanks, Prof. Kello. You mentioned cost, and that's really where we're going to go to the first question. There are several questions that we will take now, and what I'll request is when we call out your name, please go ahead and ask your question in a very brief manner. So the first question that we will go to would be Eric David Osmos from Philippines, and he has a question on cost of renewables. Go ahead, please.
Good evening from the Philippines. I'm Eric. I'm an MD PhD student. I just want to ask because one of the comments I've heard against renewable energy is that it is more costly and less, such as coal and oil. What are your thoughts about this?
Certainly in the United States, that's not the case. So we look at the lifetime cost, not just the capital cost. Remember, once you build a solar facility or a wind facility, the fuel is free. It needs almost no one to look after the facility. So it's very low cost operation once it's up and running. And I think it's just the public has turned against the utilities. I don't think they'll be allowed to build any more coal power plants in the United States. And I should emphasize, one of the other questions, geothermal is something we're looking at. That's good. And also in New York State, we're trying to keep all the nuclear power plants running as long as we can, because they're basically clean energy once they're up and running. So I think renewable right now, certainly in the US, is lower cost than a coal power plant.
Thank you for that. Thank you.
I completely agree with that. For actually, renewables is probably the lowest cost than coal in most parts of the world where solar is abundant. Thank you, Eric. I'd like to move next to Richard from Germany. And Richard has a question that would also cover nuclear.
Hello, it's nice to be here, and I'm very happy about this. I'm from Germany, and as a physicist, I have the feeling that the public discussion about nuclear power, at least in my country, is largely dominated by fears and fallacies rather than guided by facts and science. So my question to you is, when talking about our future energy mix and carbon neutral energy supply, which is of course very important, which role do you see for nuclear energy, so both fusion and fission, in covering our worldwide energy demand? Thanks.
I wonder, Prof. Kajita, do you want to address that? You may be on mute.
Thank you for this question. Well, since I'm an experimental particle physicist, maybe I should say a few words about the nuclear power generations. First, was nuclear power reactors are attractive because they generate energy by nuclear fusion processes and therefore do not emit carbon dioxide. On the other hand, when we speak about the Japanese case, just about 10 years ago, there was a very serious accident in nuclear power reactor in Fukushima in Japan. This accident told us that if an accident happens, there are huge impacts to the environment and to the people living there. Therefore, in Japan, people are still discussing how to use the nuclear power reactors in our future. So this is a very difficult discussion. Of course, on the other hand, technology improves. There are some other new technology. One such example is the small modular reactors. I do not know the details of these new types of reactors, but there are several R&Ds going on to prove the concept of the small modular reactors. And these reactors are much easier to cool down than the conventional nuclear power reactors, and therefore much less probability of accidents. With these technologies, maybe very serious accident like that of Fukushima may not happen. So therefore, we should continue the R&Ds. And actually, I want to say one more thing. That is the nuclear fusion. Clearly, DT reactions do not produce radioactive material as the fusion product, which is very nice. And I hope someday we can use electricity produced by fusion reactors. However, if we think about the electricity generation by commercial companies with the nuclear fusion reactors by 2050, well, I have to say, I cannot be optimistic. Well, basic researches on high temperature, high density plasma aiming for nuclear fusion have continued for more than half a century. But we still have to continue the basic researches on these plasmas. For example, ITER, International Thermonuclear Experimental Reactor, which is an experimental reactor, is going to begin the operation in 2025. I hope they produce encouraging scientific results and therefore they move on to the next stage. But if we think about the timeline, I think these reactors may not be available commercially by 2050. Therefore, in order to achieve the carbon neutral by 2050, we cannot rely on nuclear fusion. So, but in summary, I think that nuclear fusion and nuclear fission could contribute to some extent to the carbon neutral, but we should not expect too much to them. So, therefore, I would like to encourage young people to continue working on the basic research and R&Ds contributing to the carbon neutral in 2050. Okay, that's all from me.
Thanks, Richard, and thanks, Prof. Kajita. What I'd like to switch to next is a question from Amit Gaurav from Singapore. And this broadly speaks also about human impact and human behavior. Amit, do you want to come on screen and ask the question? Could we invite Amit? Amit is not online. Okay. In which case, could we move on to the question from. Sorry. Okay, go ahead.
Yeah, so my question was to like, are we ignoring something simple or something being like overlooked by the governments or the people, which has like massive impact on the climate change, or to mitigate the problems, but it's not really being publicized, or we are missing out on it. Like, but it has a huge impact, but it's not being properly publicized, or people are not working towards it.
Prof. Kello, would you like to address that, or someone else?
Yeah, well, it's a difficult question. Asking a scientist about something we don't know, it's always a little bit of a touchy problem. My understanding right now is the level of predictions and the level of understanding of the chemistry of the atmosphere is really good. And people, if you look back at the prediction made in the 80s, they're amazingly matching the situation right now, only on the basis of a simple atmosphere, essentially, when you have the water and the usual element and the extra CO2 we're providing. So I would not expect, I think, a massive change. Of course, the more we're changing things, the more the Earth is reacting to that. And we are about to change, to some point, the imbalance by the oceans. And we're going to change sooner or later the stream into the oceans. And this will, of course, impact on the modeling. But I guess that the chemistry of all this is quite well understood. And it's not really an issue about the rationality of it. I think this is the human production that is changing it. So then you can identify what is the main human productions, and right now is the amount of CO2 that was quietly embedded into the crust of the atmosphere, and then we're bringing this out into the air, into the atmosphere, and this is the main element right now, which is driving essentially the rise of the temperature. And the rise of the temperature is driving a lot of secondary effect, and that has, in some of them have an amplification effect, others have a damping effect. And this combination of this whole effect together is essentially what people are trying to model. And it has to be considered with the local element, all this together. This is the purpose of this very intensive, computer-intensive modeling of the Earth atmosphere. So in a short, I don't expect something that we're massively missing something. I think what we may be missing here is to perfectly acknowledge in a way the bizarre and the awkward is the human sociology and how we're reacting to an effect which you cannot affect on a short term, but on the long term. And we're very bad at that. I mean, usually within 20 years, and it has been shown in the study of the earthquake area, if there is no earthquake for more than 20 years, people start to rebuild the house at the same location. They just forgot that it was a bad place to build a house. And then 50 years later, we're all surprised because there are thousands of people dead because it was a location that was known to be bad to build housing. So humankind on that way is very bad at dealing with the long-term aspect because we have difficulty to project ourselves. But that's, to me, is the main missing element. How do we acknowledge globally that we're dealing with an effect that will need maybe 100 years to see the full extent of the damages on the society? And that would deserve certainly more studies, which is related to the psychology and the sociology essentially here.
So basically, we lack the, long-sightedness. We just basically forget that all those risks.
Got it. Amit will come back and wrap that up later.
Thank you. Thank
you.
you.
So far spoken about renewables, we've spoken about nuclear. I think it's time to speak about hydrogen. And we have a question on hydrogen from Hongen Yu from China. And although the question speaks about applicability to Japan, I think hydrogen is applicable all over the world. And I would invite anyone from the panel to address it, please. Go ahead, Hongen.
It's an honor to meet three Nobel laureates face to face. In our laboratories, we make batteries and hydrogen storage materials at the same time. So I want to ask you a question: that which one will you think will be the dominant in the future, electricity or hydrogen?
Maybe I can have a go at that. They have to go together.
Yes.
Okay.
If you're going to have hydrogen-powered trucks, which is what the United States is thinking for long-haul, large trucks, we'll have hydrogen generated by wind energy, but a fuel cell only has constant output to be most efficient. So you need a large battery for acceleration and for regenerative braking. So they go together, they're both electrochemical in nature, so the same skills. I think we need to combine them. Right now, it's too expensive to make green hydrogen, so we need a lot more research on catalysts and how to get that cost down. Now, I think most people think if we're going to go to electric vehicles for large trucks going from coast to coast in the United States, they're basically going to be fuel cell powered using hydrogen, and you'll have hydrogen fueling stations across on the interstate. So I would say the two go together. Neither one can win out because they've got their own strengths.
Thank you.
I may add something here. I think there is like a triangle. This is the magic triangle of energy. There is three elements that has to go together. There is the generation of the energy, there is the transport of the energy, and the storage of the energy. And they all have to go together. So any progress you're making on one at the end will have an impact on the others. And at the end, we should be able to build up the magic triangle where we optimize the generation at the right place for the given specificity, what is good there. And if there is a lot of sun, you use a kind of a solar panel. There are places they have no sun, but they have maybe geothermal energy. Other places they may have more wind, and we can play with all this together. Then you need to fix the transportations, and that's a big challenge. And when you look back in the past, we have not made a real progress in 200 years. So my bet is the future is on transportation. If you want to change the world, you have to change the way we transport the electricity. Get rid of the copper. Find a way that doesn't leave energy along the way. It's kind of superconductivity material or whatever that you can employ for transport energy. And then the storage, there has been this massive amount of progress that we've been told by Stanley. I mean, that is really going in an amazing way.
Great.
Okay, thank you very much.
Thank you for a very good question. We'd like to go next to a question about technologies which have not been discovered yet. And really the question is coming from Toma Yamagoshi from Japan. Can we have Toma on the screen? And some of these, just for the panel members, this addresses perhaps the breakthrough technologies that we are all yearning for. Do we have, okay, here he goes.
Hello, can you hear me?
Yes. Go ahead, please.
Hello, my name is Toma Yamagoshi. I study economics in Kyoto University. I have a question. These days, emissions of greenhouse gas is increasing because more and more countries started economic growth. I think renewable energy is too costly to fulfill all the demands. Although global warming cannot be stopped, after passing some point, people may demand electricity by emitting more greenhouse gas. Do you think some new technology change this situation? If so, please give me an example.
Well, first of all, I think it is, as Stanley told us, it is not true that the electricity generation by oil and gas are the cheapest. It's not true. Renewable energies are cheaper. So we have to change our mind. And this change of mind should also be applied to the developing countries. Okay.
Well, I may comment on this. I think the developing countries have a real opportunity here to do different. I mean, this renewable energy, they're coming with another concept. We're not anymore having this kind of massive allocation that create a large amount of energy and has to be distributed. You can come up with a more distributed systems when you have plenty of smaller systems, hydrogen-based, wind-based, solar-based, that would be locally supporting some demand locally without the need of transporting the energy. It's a bit like the phone. I mean, we right now we realize in some of the country they won't need to build telephone lines because it's not needed anymore. You can use a completely new mechanism with everybody having a cell phone. That's a complete different mechanism here. So I really hope that we're going to break this kind of perceptions that we have to follow the old rules in a way into that, and we're trying to be really creative. No, predicting what is the next breakthrough is by essence is impossible, because the next breakthrough is a breakthrough, so you can't predict the breakthrough. But there's something that is for sure. The more people will be working, looking for a next breakthrough, or the more you invest into the future, the more likely you're going to find something. So I think here, the countries that are willing to invest into the development of more energy, they really have to ask themselves, what is best for them? Do you want to have something on the very short term that would work for maybe to make 5, 10, or 20 years that will not deliver something very useful and a lot of problems later on? Or do you want to just think about something a bit more long-term that pave the way for a real future into these countries? And I look back at the developed countries, they have not been developed in a day. It takes time to develop the network and the support and the society that is going to use extra energy. So I think really here it's essential for people dealing with the economy to only consider all these elements. I mean, this short-termist, long-termist, and whether you want to invest. And again, my advice for people that are, I've been talking with economists quite a lot, and my advice is always the same. Well, you guys get out of your bank, go to talk to the scientists, go to the labs, because this is where the future is being developed right now. If you want to have an idea what comes next, go to university, invest into university, visit labs, talk to scientists, get a feeling what is coming next in the next 10 years. Get away from your books and your places. And that would be, I think, the way I would try to promote the future developments in any country willing to invest into this topic for the future.
Great. Thanks.
Professor Kelts, how long do you think need to spread carbon neutral in the world? Complete. How do you think how many times to complete carbon neutral?
Thomas, if you don't mind, we will take that question as the concluding comment. So hold on to that thought. We'll come back to it, and our panel will respond to it.
Wow.
What I would like to go to next is Christopher Lee. Christopher has a little bit of a provocative question which relates to whether we are stalling on climate action. Go ahead, Christopher.
Hi. Yeah, so I actually really agree with what Prof. Queloz was saying just now. Say, innovation is the way that we're going to get out of this. And really, my concern is that all this talk about carbon neutrality and climate change, it might be masking the real problem. Energy source, like humans have not been carbon neutral since we discovered fire, right? So we need energy, and really energy is the source of it. And maybe alluding to what Richard was saying, maybe somebody could comment also about thorium as a nuclear power source. It's much safer, but research in it really has not had the same political will behind it. Only really China and India are doing it, and I'm just wondering, why are Western democracies not picking up on this sort of like developing new energy sources and just taking a stalling, some kind of like a stalling mechanism instead?
Well, I just want to react to something you said. So we've always been bringing the CO2 into the atmosphere. That's not true. I think it started when we started digging out the coal out of the earth. Before that, the society, they were essentially using the solar product transformed by the nature and the wind, and that's it. They were not really having impact. So I'm not saying we should go back to that time, but essentially we have had real developments of the society without the coal. So I think the coal, to me, if you look back in 1,000 years, will be looked as the worst possible solutions to bring energy, and we will have kind of fixed it, hopefully. Otherwise, if we don't fix it, in a way, there will not be a 1,000 years future for all of us. So that's pretty clear that when we be looking back at that, that would be seen as an episode, the very poor episode of the humankind using the worst possible mechanism to produce energy. Well, again, the most powerful energy which is available to us is very simple. It's the origin of the world system, of the life on Earth, is the sun. So the sun is the main dominant energy available. That comes top. And after you get the radioactivity into the Earth, that brings some temperature, and you can bring this temperature out in some way, or you can directly use the radioactivity event as being source of energy. These are the two main sources. And then you can use the gravity because of the moon going around, and the moon is producing a very interesting gravity event, which is known as the tides. So these are the energy which are infinite, at least until we still have a sun in such a phase right now, which is still going on for a couple of billion years old. So it's still fine.
Thank you, Prof. Kelo. We have had so many questions, and I'm afraid we're not going to be answering all of them. But perhaps the next question I'd like to go to would be from Francesco Bernascoli from Switzerland. Go ahead, please. Can we have Francesco on the screen?
Hello, hi. Can you hear me? It's a pleasure to be here. I wanted to ask you a question about the CO2 to fuel reduction, because apparently we can bridge the energy demand between day and night, day and night cycle, but we are having trouble bridging the demand of energy during the winter periods. Any thought about that? Thank you.
I think this is a very important question. In fact, well, if you use the solar panel, then the amount of the electricity that can be generated during the winter is minimum. So we have to think about the other ways. One is the wind, the other is the large-scale energy storage. Well, but unfortunately, I do not know the concrete example of these technologies. But certainly, you should try to develop this kind of technology in order to really achieve the carbon neutral.
Great. Does anyone else wants to chip in?
Yeah, maybe just to open up a little bit. Again, it's a matter of creativity here. I was reading recently a paper about a potential use of the gravity as a source of storage. And you can imagine when you have extra energy, you bring blocks of stone or whatever you like, and you build a very high pyramid. The pyramid can be 1 kilometer high, and then later you just use the fact that these blocks go down. It's a bit like the hydro storage of the energy that we know very well in Switzerland, from Switzerland. So this is this kind of mechanism. I don't say it's a solution, but I want to mention that it's a matter of creativity, and I think we have demonstrated very poor creativity until the 80s, until we start facing the reality that we cannot continue like that. So we just have to acknowledge there will be no future for us if we don't stop this madness. So there is enough creativity into the knowledge, into the developments, to trying to find solutions, and we should just unleash this and let the people being able to go this way and explore opportunity. And I'm afraid right now these people have been prevented to do so, essentially because it was not seen as important and not a good topic for fundings to invest into the future. So we need more investment. It's not only about the government, it's also about the private entreprise. They have to understand they need to invest. And we have some foundations that have started quite at high level to start investing that. But that's not enough. We should have an understanding by the whole society that it is worth investing into this topic for our own survival.
Great. Thank you, Prof. Kelo. We have probably time for just one last question. And I'd like to invite Isabel to ask that last question before we go to the conclusion section.
Hi, everyone, and thank you so much for such a great conversation so far. So I'm a PhD student who's working on energy storage technologies at MIT right now. And, you know, honestly, I just think that we're running out of time kind of faster than we realize. And so as researchers, how can we be sure that these technological changes that we're working on are implemented in time to address climate change? So is it just a matter of, you know, working on technologies in the lab until they're cost competitive with the old way of doing things, or can we really do more here?
So, Isabel, I think this is a real challenge in the United States because industry doesn't really want to invest the money to take it from the lab to a commercial product. They're much happier going to, say, Japan, South Korea, or China and buying the product there. So many of us right now are pushing to get the government to invest more money, very much along the lines of what Europe is doing. Europe's put in, I think, well over $1 billion into energy storage to make sure it is a European business. And you know, that includes everything from the supply chain all the way to the finished product and using renewable energy to make the product. So it really needs, I think, top-down government help, but industry has to be willing to invest for the long term. And in the US, they're just not willing to do that at the moment. So the incentives have to change.
Great. Folks, we have many questions which are on the website, but we really don't have time to cover all of it. What I'd like to invite each of the panelists to do is to make some concluding remarks. And perhaps, you know, one of the questions raised by Toma earlier is what else needs to be done between now and 2050 is a relevant question. There's also another really interesting question from Joram, which asks about carbon negative sources of energy. There's a wonderful question on social education. I wish I could read out each of these questions, but if you could please, perhaps in the order that we started, Professor Whittingham first, and then Professor Kajita, and Professor Kelo, could we have some concluding remarks from you in terms of a little bit of crystal balling, perhaps a little bit of what needs to be done in basic sciences for the next lap in terms of addressing climate neutrality? Over to you, Prof. Whittingham, please.
Yeah, I think the big issues are if we're going to solve our future energy changes, it needs us all working together. This means we've got to break down the barriers between the disciplines. So we need the scientists and the engineers working together, but we've got to have the economists there, the policymakers, because in the end, it's the governments that decide what we're going to do. And in addition, we can't solve it by ourselves. We have to break down the barriers between the countries and let the scientists move around, the engineers move around. And it may not be a big issue in Japan and Switzerland, but the issue here, we have to make sure people realize that facts matter and that we have politicians willing to listen to science. I know those are rather high level comments, but I think everybody has to work together. You know, at least several of us are getting on in years. We need young blood in the field who come up with totally new ideas and haven't got the blinders on as to what we've done for the last 30, 40 years. So I just encourage all the young folks, do something different, don't do the same thing, and get excited about what you're doing.
Great, thank you. Prof. Kajita,
yeah,
over to you.
Okay, well, certainly we have clear milestones, which are reducing the carbon dioxide emission by factor of 2 by about 2030 and carbon neutral by 2050. Well, actually, 2030 is tomorrow, and 2050 is the day after tomorrow. Therefore, I think we have to largely rely on the existing technologies for such short-term goals. However, it is also true that our technologies are not good enough to really achieve carbon neutral by 2050. So I hope that various basic researches and R&Ds are carried out to achieve carbon neutral or even carbon negative. By the way, In addition to technologies, the leaderships by political leaders, government and commercial sectors, and academics will be really important. I think it's not possible to achieve carbon neutral without the strong and coherent leadership from the various sectors. And finally, I want to add one thing. Even if we achieve carbon neutral by 2050, the temperature might rise to approximately 1.5 degrees C above pre-industrial level. Various scientific studies tell us that even that 1.5 degree temperature rise will have significant impact to our life, environment, and even to the earth. So there must be really huge amount of issues for our sustainability. So we have to extend the scientific studies on the sustainability in 2050 and beyond. Okay, that's all from me.
Thank you. Prof. Keller, over to you, please.
Yes, well, I think we have unleashed a monster, and that's why I was just suggesting to stop being mild and talking about climate change, but really maybe talking about the human impact, the change of the human impact on the climate here. And once we have acknowledged this fact, I think there is another fact I think we have to acknowledge that, well, there is no magic wand or magic sword to kill the monster. I mean, this is not something that will be done in a day. We have really to change the attitudes to what we're doing. It's a global society problem we're talking about. And in a sense, all of us have something to do with that. We can do it on our own life by a lot of tiny decisions we're taking, and we can try to acknowledge there is no applet that compute your carbon footprint. Well, maybe we should get used to just know what is our own, what is the impact of our own decisions or whatever we're doing. I'm not only talking about using a car and a plane. It's in anything we're doing, we're buying, the way we're living, and that is certainly something very profound. And on that sense, I feel a little bit guilty because I think all generations, we have completely failed on this because we have not really acknowledged how severe was the problem in the 80s. And no, there is a new generation coming, and I think this generation is fascinating because first, they're really embarking to this topic. They really understand much better what it means, and I think she's really ready to fix it, even if it has an impact on the way we're living. Sooner or later, it's gonna work. And sooner or later, the society will respond to that. I mean, society is not crazy. We don't want to self-suicide. So we will want to get a solution to that. And I understand, I mean, this MIT student saying, oh, what can I do? Well, in a way, you should tell us what you need. That's really what you have to do it. And you should tell us very loud and very clear, because we have to respond to your need. You are the problem solver in a way. You are not only by your research activity, but in the way you will interact with your peers in the society and the way we will communicate in the society. Some countries are better right now than others, but look, in 10 years' time, 20 years' time, I think if you look with some altitudes, we're all in the same boat, and in a way we're all sharing the same kind of bad habits. So this is really what is the challenge. So in terms of time scale, well, clearly the sooner is better. We know already today the temperature we know will change by 2 degrees. It's too late to go backwards on this. We know that some cities will be underwater. No, New York is building walls that cost billions to protect from the rise of the water. So we're only where we are. Well, the more we wait, the more this will increase. There will have no forest in California because they will be burned down till the last tree, and all this is going on. So the sooner is the better, but there is practicality, which is a response to the society into that. And until the society has swallowed the hard impact of this, I'm afraid we will have to live with still a lot of damages in a couple of years. So in a way, I'm very optimistic to see how many people are attending this kind of meeting and get embarked into trying to fix it. But another way, I'm very pessimistic on the reactions, the kind of it is so slow for people to just acknowledge it. But we do what we can, and surely if you don't start, you don't reach the goal. So let's start it as soon as possible.
Great. Thank you. Folks, to summarize what we covered today is the challenges from a climate neutrality perspective, the routes towards mitigation. We looked at new avenues and new solutions. We didn't cover all the topics. We didn't cover circularity. We didn't cover sufficiently geothermal or carbon capture, but we covered a lot. In the concluding comments, really what we were left as takeaway message from Prof. Whittingham is truly multidisciplinarity. What Professor Kajita left us with is basic science would be the spearhead that would deliver the solutions. And what I take away from Prof. Kelo is societal activism and optimism that would lead us to climate neutrality by 2050. Thank you very much for joining us, and have a good rest of the day. Bye-bye for now.
Bye.